Hello everyone, Megan Kane from the Stata YouTube channel here. Today I'm going to show you how to make a table of descriptive statistics using the dtable command in Stata. I will use the nhaynes2l dataset that you can load with the webuse command. I start by navigating to the Statistics menu, Summaries, Tables, and Tests, Tables of Descriptive Statistics. This opens the dialog box for the dtable command. At the top, we select a variable for which we would like descriptive statistics. I select age. I click Submit to keep the dialog box open, and I can see that it created this simple table that says Summary. It has my sample size, and because age is a continuous variable, it displays the mean and the standard deviation in parentheses. If I want to add a factor variable or categorical variable, I click on these three dots and then select the variable, such as sex, and add it to var list. Notice that it adds an I dot in front of it. This is how Stata denotes that this is a factor variable. I select OK and Submit, and now we see both variables in our table. We still have the mean and standard deviation for age, as well as the frequencies and percentages for our two categories of sex. Let's go ahead and add some more variables to our table. Now, the first trick I'll show you today, instead of writing out I dot in front of every factor variable, what I'm going to do is open a parentheses after the first I dot and then list all of my factor variables inside, race, diabetes, and close my parentheses to denote that all of these variables are factor variables. Then I add continuous variables weight, height, and BMI. I select Submit. Now we can see all of these variables in our table. From here, we can check Describe Variables by Group, and I'm going to select the very last variable in this dataset, highbp, as my grouping variable. When I click Submit, you can see that this table now has three columns. One column for the subsample where high blood pressure equals 0, one column for the subsample where high blood pressure equals 1, and then a total column with the full sample. If you're not interested in seeing the total sample, what you can do is where it says Total Sample Statistics, select Suppress. Then we submit. Now we have a two-column table. We could also add tests comparing groups by going to Tests Across Groups and selecting Show, and submit again. Now we get some notes telling us what tests were run. For the continuous variables, it uses regress, or in other words, just a t-test, because we have a two-level grouping variable. And for the factor variables, it uses a Pearson chi-squared test of association. Both are testing if there's a difference by group, and we can see their p-values listed here. Now let's go through some of the common options you might want to add to your dtable. As always in Stata, use if or in if you want to create a table with only a subset of your dataset. If you have a weighting variable or your data was survey set, you could select those options. The Sample tab refers to the sample statistics. This top N category here that tells you the sample size and percentages of the groups. We could change the placement of this, for example, to stack in the column header, and then we could see it up here instead of within our table. We could also change these statistics, but I'll stick to the default frequency and percent. The Continuous tab has to do with what statistics we show for the continuous variables. I click Create, and then I could leave the variables field blank to have these statistics pertain to all continuous variables, but I just want these changes to pertain to one particular variable, age. Instead of mean and standard deviation, I would like to see the median and interquartile range for age. For the test, I'm going to use a kwallis. I say OK, and when I submit, we have the median and the interquartile range. We also get this note up here telling us that this p-value corresponds to the kwallis test. The Factor Variables tab has the same setup. Again, I click Create, this time leaving the Variables field empty to select all factor variables. I'll leave statistics with their default factor variable frequencies and factor variable percents, but I'm going to change the test from a Pearson chi-squared to a Fisher's exact test. And click OK and Submit. Once again, you can see that the note has changed, telling us that we've now used the Fisher exact test for group differences across factor variables. Composite results are a composite of results, or results that are bundled together within a column. For example, instead of putting median and interquartile range just one after the other, what we could have done is create a composite result with median and interquartile range separated by a semicolon. To do that, I click Create, and I have to give this composite result a name, so I'm going to call it mediqr, and I'm going to use the median and IQR to create this composite result. As a delimiter, I could just type a semicolon, but what I'm going to do is open quote, semicolon, space, close quote to add a space after the semicolon. OK, and submit. Nothing has happened. That's because we need to go back to continuous, edit, and instead of putting median and IQR in our statistics, we're going to change that to mediqr, the composite result that I just created. I select OK, submit, and now we can see our composite result in our table. You can see that my median and IQR really only need 2 digits. So I click Formats, Create, and then select Numeric Format. Fix numeric to specify that I want exactly 2 digits total with exactly 0 digits to the right of the decimal. Instead of applying this format to all results, I'm going to apply it just to the mediqr composite result. I click Accept and Submit. Now we can see this is just 2 digits, semicolon, and then the IQR is also 2 digits. To finish up, I will add a title, Table 1, Descriptive Statistics by Blood Pressure Status. Now we can see that title here. I could also add notes. For example, median, semicolon, IQR for one note, and mean, parentheses, standard deviation for my other note. Click Submit, and you can see those populated below. Finally, I can export my table to a wide variety of formats and call it Table 1. I select OK to submit that command and close the dialog box. Before we move on, let's take a look at the column headers in our table. Notice that high blood pressure says just 0 or 1. That's because if we look at that variable, we see that's how it's coded, 0s and 1s. It doesn't have any value labels. If we wanted to add value labels, what we could do is select highbp, unlock the properties, go to Value Label, and click the 3 dots to create a new value label. I'm going to create a label called Yes, No, where 0 is going to denote no, and 1 is going to denote yes. I say OK, and this has created a new value label. What we need to do now is attach it to the highbp variable. Now, if we browse this variable again, we can see that it's no's and yeses instead of 0s and 1s. When I rerun my dtable command, you can see the column headers have also changed to no and yes. One last trick before I go. Another way we could have changed these labels is with the tables builder, which would also allow us to make a wide variety of other types of formatting and style changes. To do that, we navigate to Statistics, Summaries, Tables, and Tests, Tables and Collections, Build and Style Table. This is the Tables Builder. We can see a preview of our table below. And above that, it's telling us that variables are used to create the rows of this table, whereas highbp and results are used to create the columns. If we look in this section here, we can see all the different customizations we can do with the collect system. I'll start by editing level labels. I just click, and then the dimension I want to change is high blood pressure, which has 2 levels, 0 and 1. You can see that these are currently labeled no and yes because by default, collect uses the value labels for that variable. But if I want particular labels for just this table, I could do that here. Instead of no yes, I want to put in the range of blood pressure for each group. Less than 130/80 mmHg and 130/80 mmHg plus. Then I really don't need this header title anymore, so I scroll down to show hide header content, select dimension in all levels, and then once again select high blood pressure. For title header style, I select hide, then OK, and we see that high blood pressure has disappeared. At last, I will export my table again, this time to a PDF, still calling it Table 1, and select OK. When I close the Tables Builder, you can see the collect commands that it issued for us, and then you can see it also created this file, table1.pdf, that we can open from here. And that's how you create a table of descriptive statistics in Stata. See you next time.